Here this question is asking, determine the C transform of the following signal. And here we have two signals provided. One is with some points, and the other one is with a piecewise function. Okay, now let's look at the first one, the A part. Okay, in the A part we have x of n is equal to 3, 0, 0, 0, 0, and 6, and we have arrow here. This arrow means this is at 0 location. Okay, and -4. Now first thing what you have to know is you have to know the equation to transfer from time domain to C transform. So in order to do the C transform, what we do is, if you have a time domain function provided, we put it in this equation, summation n x of n c power minus n, some equation. Now what we have to do is we have to do this for each point and sum them together. That is what this one means. Okay, now let's go ahead and do that. So we only have to worry about wherever the value exists. If it's 0, we can just leave it alone. We don't have to do anything with that. And x of n will be replaced with whatever the number we have here. So here x of n, if I look at this is 3 right here, and the 3, if you count from 0, if this is 0, then this is -1, -2, -3, -4, -5. This is at -5 location. So we are going to have c power -5, which is going to make it to +5. Okay, and then the next point we have is 6. This is at 0, so c power 0, which is 1, so we don't have to write that one. And the next one we have is 1 right here, and then that is z power -1. So we can just write it as c power -1, because if you multiply z power -1 by 1, that's just going to be c power -1. So we can just write it as c power -1 right here. And the next one is -4 z power -2. So this is plus minus, so we can just put a minus here. Okay, and this is a C transform. This is our final answer for the A part of this question. And if they ask for the region of convergence, then the region of convergence of this one is exists at the whole C plane. Okay, so the region of convergence exists at c is equal to 0 and z is equal to infinity. Actually, it doesn't exist z is equal to 0 and c is equal to infinity, and it exists all other places. The reason is, one of the property of the region of convergence for Z transform says that if x of n is a finite duration two-sided sequence, then its ROC is the entire C plane except z is equal to 0 and c is equal to infinity. So we can just in a short form we can say region of convergence is greater than 0. Okay, z is greater than 0 and less than infinity, like this. Now let's look at the B part of this question. The B part of this question is a piecewise function. We have x of n half power n, and it only exists when n is greater than or equal to 5. Other than that, when n is less than or equal to 4, it is 0. So if it's 0, we don't have to consider that part. We only have to consider wherever something exists. So the value we have is when n is equal to greater than or equal to 5, we have this function right here. So that is the only part we have to take care of. Okay, let's go ahead and do it in the next page. So I copy this piecewise function x of n, and that is equal to half power n, and this only exists when n is greater than or equal to 5, and otherwise it's 0 when n is less than or equal to 4. Okay, so this is the only part we have to take care of. Again, to transfer a time domain into C transform, we have to use this equation, that is x of z is equal to summation of n x of n c power -n. Okay, now the limit is starting from 5 and goes up to infinity. So we can say n is equal to 5 goes up to infinity, and the x of n is the function that's provided right here, which is half power n, and that one multiplied by c power minus n. And we can combine this c power minus n this one by bringing this c power minus n to the denominator. If we bring c power minus n to the denominator, that's going to become a z power n. Since both of them have the power n, we can combine them together like this. Okay. Summation n is equal to 5 to infinity, and I put 1 over 2z and whole power n. Okay, that is same thing. And this is our Z transform. But here we can do another thing for this kind of Z transform. Like we have to see if we can bring this pattern right here. There's a pattern that is, let me put it in a different color. So there's a pattern, like if you see a pattern that is when summation n is equal to 0 to infinity, and you have something r power n, and that can be written as 1 over 1 minus r. Currently I cannot convert this one into this pattern because I don't have n is equal to 0 right here. I have to have a 0, infinity, and a something with a power n. If I have it, I can convert like this, but I don't have it right now, so I cannot convert it. But I can see if I can bring it to that pattern. So in order to bring it to that pattern, what I can do is I bring a new term called m. Let's say m is equal to 0, then goes to infinity. And if I put m is equal to 0, then in order to bring the equivalent expression like this, I have to add a 5 to it, because I reduced 5 units down. Like initially n start with 5, I'm starting with 0, which means I have to add a 5 to this. So I had to put m plus 5 here instead of n. Okay, so which means I still cannot bring it to this pattern, because if I want to bring it, I had to have m alone only. Then only I can do it. But here, if you notice, if you have power adding, then these are multiplication. Like when you multiply, the powers will add. So you can also write this one as summation m is equal to 0 to infinity 1 over 2z, and you can write it as 1 over 2z power m, 1 over 2z power 5 as well. This 1 over 2z power 5, there's nothing related to m, so this is just a constant, so you can move it to the front. 1 over 2z power 5 right here, and summation m is equal to 0 to infinity 1 over 2z power m. Now if you notice, we have brought this pattern right here. We have n something is equal to 0 to infinity, and we have the same power right here. And if you have something like that, then that can be replaced with 1 over 1 minus r. The r is whatever the value we have powered. Like here in this case, 1 over 2z is the r. So I have to do it in the next page. The first term remains the same, 1 over 2z power 5, so I keep it as it is, 1 over 2z power 5. And the second term is can be converted like this, 1 over 1 minus 1 over 1 minus, instead of z I put this one right here, 1 over 2z. Okay, so this one multiplied by that, and that's our z transform. Okay, and you can also, instead of this one, you can also write this one as like z power is, if you like it, like z power minus 1 over 2 power 5, or and also this one 1 over 1 minus z power minus 1 over 2, but it's the same thing. Okay, and that's it for this video. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.